deals with something about a triangle, right? Everything that we saw on the quiz yesterday, we were doing center, different kinds of centers, centroid, circumcenter, incenter, different kinds of things with the center of a circle. And so today we're not going to necessarily deal with like a center of a circle, but we're still talking about different things in relationship to a triangle, okay? And today the main topic is talking about what we call the mid-segment of a triangle. And a mid-segment is kind of like a sentence. If I break down the word, mid means middle. Segment is a segment. And so segment, that's in the middle. Well, what's it in the middle of? And so what we're going to see here is we've got M. What would we say about M? What do we know about M in this picture? What's something we could say about M? It's in the middle of AB, yep, because I know these two sides are, or these two pieces are congruent. So M is the midpoint of AB. Same thing over here. P is the midpoint of BC. And finally, N is the midpoint of AC. So M, P, and N are all midpoints of the three sides. We have a triangle, we have three midpoints, we have three sides, okay? If I connect those 3 points together, then that would give me the 3 mid-segments of this triangle. Okay, so a mid-segment is a segment that connects the midpoints of two sides of a triangle. So what we would say here is that MP, MN, and PN are all mid-segments of triangle ABC. Okay, so if we have a triangle and connect all the midpoints of that triangle, we'll actually have 3 mid-segments. Okay? And sometimes we'll deal with all 3 of them. Sometimes we'll just focus on one of them, like for instance MP. Now, what we're also going to do today is talk about the relationship that the mid-segment has in this triangle. And there's a couple of pieces of information that we're going to find out that we know about the mid-segments. And so what we're going to do on this first example is we're going to talk about what that mid-segment does. In this case, we only have one mid-segment. We have MN. And we want to show that it's a mid-segment. So there's 2 things that we're going to prove here. Okay, we're going to prove that MN is parallel to JL. So in order to prove that MN and JL are parallel, what would we need to know about those 2 segments? How do I know if 2 segments are parallel? Okay, they never touch. Okay, that's true. Okay, how do we know they never touch? What piece of information would we need to know? Slope. We got another slope. And what would be true about their slopes?
Opposite signs and also flip.
Okay, and that would be for perpendicular. Okay, if they're perpendicular, if we want to see if they form a 90, they would be opposite reciprocals. But parallel, they're just exactly the same. If one goes up 3 over 2, the other one should go up 3 and over 2. Okay? And so on this one, we're going to find the slopes of both of these. We're going to find the slope of MN, we're going to find the slope of JL, and we're going to see if they're the same. Okay? And so the easiest way, especially because I'm given a graph here, is just to do rise over run. And I know I spell rise a little bit funky. I use a Y because remember that Y's go on top. My rise goes up and down, my Y values, okay? And so if I'm going to go from M to N, I'm going to go down 1, and I'm going to go over 1, 2, 3, 4. So down 1, right 4. Okay, for JL, if I'm going to go from J to L, this time we're going to go down 2, and then we're going to go over 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go down 2 over 8. But what can we do to that fraction? Simplify it. Yeah, 2 comes out of each one, right? So this would become negative 1 over 4. Okay, and as I look at those two slopes, what do I notice? They're exactly the same, okay? So they have the same slope, so we know that they are indeed parallel to one another. Okay, the second thing that we're going to do is we're going to compare the length of these two, okay? And remember, when a segment is diagonal, like MN and JL are, I can't just count. I can't just go from M and say 1, 2, 3, 4, right? If it was vertical or horizontal, if it was straight up and down, or if it was straight across, I could count over, I could count up and down. But I can't do that for MN or JL because they're at a diagonal. So what's the best way to find the length of MN here? Or the distance of MN? Do we have a formula that we can use that gives us the length of a segment? Distance formula, right? Good news, we got a formula. Have we used that formula quite a bit this year? Yeah, okay. We've used it in a lot of different scenarios. So we should be able to just rattle that thing off, hopefully. So we're going to compare the length of those two. We're going to do MN, and we're going to do JL. Okay, MN, the two ordered pairs would be negative 4, 3. And 0, 2. I want to find the length of those two, okay? So here's what we're going to do. This is x1, y1, x2, y2. And it doesn't matter which one's which. You could flip those two around if you need to. Really watch your signs. So we're going to go 0 minus negative 4. I'm going to go ahead and just change that to a positive. And then 2 minus 3 squared. So 4 squared is 16. 2 minus 3 is 1. 1 squared would be 17. So that would be the square root of 17. And I'm going to leave it as a square root for right now. Just the square root of 17. And I'll show you why here in just a second. Okay, for JL, we're going to do the same thing, except we're going to use the points for JL. So we have negative 6, 1, and we have 2, negative 1. Once again, x1, y1, x2, y2. Just really watch your signs. We're going to go 2 minus negative 6, which would be 2 plus 6. We're going to go negative 1 minus 1. Two plus 6 is 8. 8 squared would be 64. Negative 1 minus 1 would be negative 2. Negative 2 times negative 2 would be 4. So that would become the square root of 68. Okay. Now, what we need to do here is this is not a perfect square. If it was a perfect square, I'd just take the square root of it, I'd get a whole number. I want to find a perfect square that goes into 68. So what would be a perfect square? So we're looking at numbers like 4, 9, 16, 25, 36, all of your perfect squares. What would be a perfect square that would go into 68? And if you're not sure, just check it, right? First thing I would do is I would take 68 divided by 4. Does 4 go into 68 evenly? Whoa. Yeah, how many times?
17.
17. Okay, so what I can do here is I could rewrite this as 4 times 17. Now what would the square root of 4 really become? 2. So that becomes 2 radical 17. Okay, so what that tells me is this is 2 times bigger than this. We're taking 2 times radical 17. This one is just radical 17. So this length is 2 times bigger than this length. Okay? And so the way that I would write that is that JL equals 2 times MN. Or I could say MN is 1/2 of JL. Okay. JL is 2 times bigger, or MN is half the size. If I said one is 8 and the other is 4, it's kind of like we did with the centroids, right? Sometimes we multiplied by 2, sometimes we divided by 2. Kind of depends on which piece we have and which piece you want to compare it to. Okay. Both of these statements are the same thing. We're just saying it a different way, right? 4 times 2 is 8. 8 divided by 2 is 4. Okay. It says the same thing, just says it in a little bit different way. Okay. So what this tells us, and we're going to talk about this a lot today, is on a mid-segment, there's 2 things that are true. If I indeed have a mid-segment, these 2 are parallel to one another. So I could put an arrow on there to show they're parallel, okay? And MN, the mid-segment, is going to be half the length of the side that it is parallel to. The one side that it doesn't touch. So these are the 2 sides that it's the midpoint of. The third side that it does not touch, it'll be half the length of, if it's a mid-segment, okay? Those 2 things will always be true today. Okay, I'm not going to do a second one because it's pretty lengthy. You're going to have to kind of walk through some problems on big ideas today where you'll do some of that stuff. It's essentially just using midpoint and distance. If I didn't have a graph, what would I do to find the midpoint? Like here, it didn't tell me what the ordered pair was for this. Obviously, because I had a graph, it was really easy to identify. If I just had these 2 points and I wanted to find what point is halfway between J and K, then I could just do the midpoint formula, right? I could do -6 plus -2, which is -8, divided by 2 is -4. I could do 1 plus 5 is 6, 6 divided by 2 is 3. So in order to find out what M is, I could just find the midpoint of those 2. And then I could do the same thing for these 2. But I don't need to do the midpoint formula in that case, right? Because I'm given the graph. And as long as it's right on an ordered pair, then there's no reason to do a formula if I don't really need to do the formula, okay? But if I didn't have the picture, then we may have to do the midpoint formula on something like that. Or if you didn't have a picture, draw yourself a picture. Put it on a coordinate plane and draw it out if that helps you to do it that way, okay? I don't have an issue with that at all. Okay, let's go to the next page. Hey, Aiden, could you take those 2 boxes, or those 2? We don't need those anymore. Are you guys taking those out? Okay. We got 4 pictures here. Which one does not belong? So because we're talking about mid-segment today, which one does not give us a mid-segment? Third one, how come? This point's in the middle, but not the other one, right? This one goes to a vertice. Okay, so this is the one that doesn't quite fit because it goes to a vertice instead of a midpoint. All of these, the rest of them, all go midpoint to midpoint, midpoint to midpoint. So it has to connect 2 midpoints. We have a midpoint on one side, but we don't have a midpoint on the other, okay? So we gotta have a midpoint on both sides in order to be a mid-segment. So the third one is definitely the one that does not fit with the others. Okay, this is what we just got done talking about. There's 2 pieces of information that we're gonna use over and over and over again today, okay? First of all, DE and AC. DE is a mid-segment. I know it's a mid-segment because D is the midpoint here, E is the midpoint here, right? So we know D and E are midpoints. When I connect D and E together, DE is the mid-segment. So what I'm going to say here is that DE is parallel to AC. The mid-segment and the side that it doesn't touch of the triangle will always be parallel. Okay? That's the first thing. The second thing that will be true is that DE will be half of AC. Or you could say AC equals 2 times DE. Either one of those would work, okay? And the reason I write both of those statements is because in some cases, if they gave me that this was 5, then this would be 10. If I told you that this was 20, this would be 10, right? So if I give you the long side, I divide by 2. If I give you the mid-segment, I multiply by 2. So it just kind of depends on which one we're given as to which direction we're going to go. But it's either multiply by 2 or divide by 2 to get from one to the other. Okay, we're going to see some examples here with some of these. On this one here, they tell us that on these trusses, these are some roof trusses, like if you're building a house, this is kind of what it would look like. Triangles are used for strength to make the roof a little bit stronger. UV and VW are mid-segments of triangle RST. So we have 2 mid-segments. We have UV and we have VW. Those 2 segments are mid-segments. They tell me they're mid-segments. I don't have to prove that they are, okay? So I want to find UV and I want to find RS, okay? So first of all, let's look at UV. UV would match up with which side of the triangle when I talk about length? Well, here's UV. The side that we're going to compare it to is RT. Now, what do I know about the relationship between UV and RT? If RT is 90, what would UV have to be? 45. It'd be half. It'd be half of that. Okay. So UV is going to be half of RT, and we know that RT is 90. So UV is going to be half of 90, which is 45. So UV would be 45. Okay. They gave me the long side. I'm going to go backwards to the mid-segment. Okay. The other one they asked me to find is RS. RS is the actual side of this triangle. There's RS. The mid-segment that it matches up with is VW. Okay? VW is the one that's given to me here. So RS is going to be 2 times bigger than VW. And we know that VW is 57. So all we got to do is take 2 times 57. And that would be 114. Okay, what would be the third midsegment of this triangle? Hey, my three points here were U, V, and W. These are the 3 midpoints of the 3 sides. Okay, we already identified UV and VW, so the third one that we have not talked about yet, and the reason why they didn't talk about it is because there wasn't anything connecting those two. But that would be my third segment. Okay, and that would be UW. Would it be okay if I called it WU? There's no difference between it, right? WU, UW, however you want to name it, okay? What do we know about WU? First of all, what would be one thing I could say about UW? There's 2 pieces of information that we can identify here. What would it be parallel to? ST, okay? Here's the side. Here's the side of the triangle. We're talking about this big triangle right here. It will be parallel to ST. So that would be one thing I could say about it, that UW is parallel to ST, because that's the side of the triangle that it's opposite of. Okay, the other thing that I know is that UW is going to be half of ST. Okay, so here's what we're going to do. If the length of the third midsegment is 81, so I'm going to tell you that UW is 81. Okay, so it's half of ST. So what would I have to do to find ST? We only got 2 options, right? We're either going to multiply by 2 or we're going to divide by 2. We got to multiply by 2 because I'm given the shorter piece, right? Good morning. Thank you. Appreciate it. Okay, so to find ST, I'm going to take 2 times 81, which is 162. Okay, but pay attention to what it's asking me. This is what we talked about on the quiz yesterday. And some of you did a really good job of this, but then sometimes we didn't do a good job of reading directions, and that's why we missed some of the questions on the quiz, because I had a lot of people that would stop at X, and they found like X equals 4. And then it said, what is the length of RS, or whatever. And we didn't take it the step further that we needed to, okay? So we have to pay attention to directions, guys, okay? I want to find VS. VS is this piece right here. Okay, I just found ST. What do we know about V? V is what? It's the midpoint, okay? It's right in between. So if this whole thing is 162, then what would VS be? 81. It's the same as the length of the midsegment. So each of these pieces are the same as the midsegment because this is half of that piece, okay? So UW is 81. SV would also be 81. Okay, and that's what we're looking for. Right over here. There's the triangle midsegment theorem. Okay, and so from now on, we can use the midsegment theorem to help us prove. Okay, in this image, AE and BE are congruent, so we're going to mark these. AE and BE are congruent. So that tells me E is a midpoint. Okay, immediately can tell that. AD and CD are congruent, so I know D is the midpoint. Show that CB is parallel to DE. Okay, CB and DE need to be parallel. Okay. First thing we know, E is the midpoint of AB. The other thing that we already talked about, D is the midpoint of AC. So we know that DE is the midsegment of the whole triangle. If DE is a midsegment of a triangle, then what does it have to be? It has to be two things. Okay, it has to be parallel to BC. It also is going to be half the length of BC. But we're not really talking about anything with length here. It doesn't say find the length of DE, because I don't have any lengths given to me. Okay? But the one thing that I can prove here is that DE is parallel to BC, because it's the midsegment. If I had to prove something here, I would just say because of the midsegment theorem, which we talked about, things that we need to prove because of the things that we now know, okay? Those two pieces of information are always true. If I had to prove, kind of like on the last one, I used it to prove like lengths of pieces of information, right? On this one, I use it to prove parallel. DE and BC are parallel. Okay, same picture on this one here. Mark what they give us. AE and BE are congruent, so E is the midpoint. AD and CD are congruent. So that tells me that D E is a midsegment. Okay. What would we know about DF? What do you think? What can we conclude about DF?
Is a mid-segment.
Yeah, DF is also a midsegment. Because it tells me this point right here. F is the midpoint of CB. Okay. So what I can do here then is, what two pieces of information do I know about DF? What's the first thing I can say about DF? There's two things I can say here. What do you think, Adrian? Okay. What would DF be parallel to? AB. Okay. DF is parallel to AB. Okay, what do I know about the length of DF? Okay, it's half of AB. Good. DF would be half of AB. Or I could also say AB is 2 times DF. That would be okay too. I'm okay with either one of those statements. Both of those statements are true. This one is 2 times longer than this, or this is half of this. Both of those are saying the same thing, just a little bit differently. All right, we're not going to do both of these because they're both essentially the same thing. But we're going to use the mid-segment theorem to answer the questions being asked. Now, this is a big old long question. We got to read it carefully to understand exactly what's going on. Okay, Elm Street intersects Cherry Street and Peach Street at their midpoints. So Elm Street intersects Cherry Street and Peach Street at its midpoints. So that right there is telling me that this is a midsegment. Okay? I'm going to get rid of that so I can see the word elm there. But we know that's a midsegment. We leave home and jog down Cherry Street to Oak Street. Your home is at point P, and it tells me that up here. Your home is at point P. So here's what we're going to do. We're going to start at point P. We're going to go down Cherry Street. To Oak Street. So we're going to go all the way down to Oak Street. We're going to go over Oak Street to Peach Street. We're going to go up Peach Street to Elm Street. We're going to go Elm back to Cherry. And then back up Cherry to home. Okay, so what we're going to do is we're going to fill in some pieces of information here. First of all, the first path that I took, I started at P and I went all the way down here. What would be this total length right here? 2.6, right? 1.3 times 1.3 times 2, or 1.3 plus 1.3. So I'm going to say 1.3 times 2. Going down Cherry Street. Okay, and then we go over on Oak Street. Well, that's 1.4 miles. Okay, then we're going to go up Peach Street, but I don't go up the whole distance. I only go up half of that. And we know this is the midpoint right here. So we're going to say half of 2.25, which is Peach Street. Okay, what would this piece right here be? What would I have to do based on everything we've talked about today? This is a midsegment because it connects midpoints together. How would I find this length? What would it be compared to? What street? What length? Okay, it's going to be this one down here, right? So what would I say? What would I have to do to get this?
1.4 by 2.
Yeah, 1.4 by 2. So it's going to be half of 1.4, which is Elm Street. And then we're going to finish by going home. We are right here. We're going to go back to home, which is 1.3 miles. On Cherry Street again. Okay, so here's what we got to do. What's 1.3 times 2? 2.6. So this is 2.6 plus 1.4. Okay, what's half of 2.25?
1.125.
Okay. Half of 1.4? 0.7. Okay, and then 1.3. Okay, and probably, you could probably type that whole thing in at once, as long as you use parentheses and make sure you watch order of operations. But if I type that whole thing into my calculator, let's see how many miles we ran. About 7.1, okay. About 7.1 miles. Okay, so that's why we're not going to do another one, because it's very similar. Just a different path that you're taking. All right, that's that's all we got.